Welcome back to The Explainer. Today, we're diving straight into something that should be keeping every CIO awake at night: the massive, hidden risks lurking inside modern enterprise AI. Everyone's rushing to deploy these intelligent systems, right? But in doing so, they're unknowingly exposing their most critical data to some unprecedented vulnerabilities. But don't worry, there is a way to lock this down. We're going to explore a definitive architectural solution to this crisis, specifically the launch of the Raksha AI model, a system that's literally designed to turn chaotic AI generation into safely governed intelligence. Let's get into it.
Okay, I want to start off with a frankly staggering metric: 83%. That is the number of organizations that reported facing at least one insider-related attack in just the last year. And here's the thing: AI systems are drastically amplifying the severity of this kind of data leakage. Think about it. You've got employees who already have deep contextual knowledge, right? They have inherent organizational trust. But when you hand them an ungoverned AI tool, you're suddenly creating massive blind spots. Shadow AI use and completely unsafe retrieval requests are driving these incidents, making that insider advantage way more potent and, honestly, way more dangerous than ever before. And the real-world stakes here, they are incredibly high. When AI governance fails, the financial fallout is severe and it's escalating fast. Just to put it in perspective, the baseline average global cost of a standard data breach right now sits at $4.88 million. But if you're in the financial sector, that average jumps to over $6 million. And those mega breaches you read about in the news, those can easily devastate an enterprise to the tune of $375 million or even more. But direct financial loss is really just the tip of the iceberg. Underneath that, you're dealing with brutal regulatory penalties, the loss of highly sensitive IP, and crippling operational downtime.
Now, we all know artificial intelligence isn't just a toy anymore. It's the foundational operating layer of the modern enterprise. We're talking about systems deeply embedded across HR, finance workflows, customer support, and even mission-critical legal infrastructure. But amidst all of these massive efficiency gains and automated workflows, organizations are missing one absolutely crucial layer: governance. It's like they've built this incredibly powerful, massive engine, but they just completely forgot to install the brakes.
And missing that governance layer is catastrophic. Why? Because it creates a direct, super fragile pipeline between highly secure enterprise memory, things like your internal documentation, legal contracts, proprietary IP, and ungoverned probabilistic AI systems. Setting things up this way is basically an unmanaged liability. You are essentially taking your most valuable organizational secrets and just pouring them into a chaotic engine that has unpredictable retrieval mechanisms and massive exposure points. It's a disaster waiting to happen.
So it's totally crucial to understand why traditional approaches are failing us so badly here. Let's compare the two main paradigms. Conventional large language models, they rely on prompt-based constraints to maintain safety. You tell the model, don't do this. But the problem is, those constraints are incredibly fragile. Prompt injections and jailbreaks bypass them all the time. Plus, these conventional models are stateless. They essentially have amnesia between tasks. There's no true continuity. On the flip side, we have the Budhi engine approach, which fixes this at the structural level. So instead of those fragile prompts, it utilizes embedded architectural guardrails entirely outside the LLM, combined with persistent cognitive memory. And to solve this escalating crisis, we're looking at the launch of the Raksha AI model, specifically Raksha M. Now, this is not just a band-aid. It's a governance-first infrastructure built directly into the execution layer. It acts as a highly customizable pre-decision policy enforcer. So rather than being some bolted-on afterthought that tries to frantically filter out bad responses after they've already been generated, Raksha M actually enforces policy constraints and blocks unsafe outputs in real time, right at the point where the AI executes its logic.
And because it operates right there at the execution layer, Raksha allows you to natively support major, strict compliance regimes. We're talking HIPAA for healthcare, the notoriously stringent EU AI Act, FINRA for the financial sector, plus GDPR and DPDP. And the way it actually achieves this compliance is really smart. It specifically supports and rigidly enforces your organization's unique internal policies and governance processes long before any AI decision is actually finalized.
One really unique aspect of this architecture that I love is the sheer amount of control it hands back to the enterprise. Instead of crossing your fingers and relying on some vendor's mysterious alignment black box, you actually own the rules. You can write your specific compliance policies in YAML. That's a standard, totally readable text configuration format. What this means is your safety protocols are fully auditable and entirely within your control. You can give regulators the exact transparency they're demanding.
So let's look at how this plays out in practice. It creates a fundamentally different pipeline. In a typical generate-first AI system, an unprotected prompt hits the data and just spits out an unsafe output. Boom, data leaked. But with governed intelligence, Raksha M intercepts that incoming prompt right at the start to evaluate context. It securely queries the semantic memory first and then acts as a behavioral check to ensure the output is safe, explainable, and fully governed before it ever reaches the user.
To pull this off, the system uses something called commitment level enforcement. Now remember, AI is inherently probabilistic, right? It's literally just guessing the next best word. But enterprise compliance, that requires deterministic guarantees. It requires absolute certainty. Enterprise facts, like confidential salary data or patient records, those have to act as hard commitments. So, if the probabilistic AI reasoning pathway even attempts a violation, the system kinetically deflects it. It completely removes the guesswork from AI safety.
Now, you might be wondering, okay, isn't this really just a fancy keyword blocker? Absolutely not. Traditional cybersecurity relies on static keywords or IP filtering, and honestly, that is completely defenseless against semantic AI threats. Raksha instead uses context-aware guardrails. When a user prompt comes in, the system actually evaluates 3 distinct layers: the semantic intent of what the user is trying to do, the strict policy rules, and the current operational memory context. It understands the actual meaning behind the request, not just the raw words being typed.
Another really critical piece of this architecture is its massive flexibility, allowing it to adapt to whatever your specific security posture is. If you're an organization that requires absolute data sovereignty, you can utilize an entirely air-gapped deployment. We're talking private training environments, local weights, zero cross-contamination. On the other hand, if you prefer a cloud setup, the system effortlessly integrates with whatever leading foundation model you already use, GPT-4, cloud, you name it. It simply wraps your chosen model in its governance layer without requiring any messy retraining.
Now, naturally, whenever we start talking about intercepting prompts, evaluating intent, and running policy checks, the very first question any engineer is going to ask is, what about latency? Well, astonishingly, these robust architectural guardrails, which again are vastly superior to those fragile prompt-based constraints, add less than 50 milliseconds of overhead to every single call. Less than 50. We're talking sub-50 millisecond latency. That keeps your applications feeling completely instantaneous while remaining absolutely bulletproof.
And you know what's even more impressive than the runtime speed? The deployment speed. Implementing this governance layer takes teams from absolute zero to production ready in under 30 minutes. It really is just 3 steps. First, you sign up and grab your API credentials. Second, you install the Python SDK, which literally takes about 3 lines of code to wrap your existing LLM calls. And third, you set your safety policies. You can either upload that YAML file we talked about earlier, or just use their no-code guardrail studio. It's really that easy.
Once you're live, continuous oversight essentially becomes your new baseline. Every single decision the AI makes is meticulously logged by the system. It captures the exact memory context at the time of the request, the specific rules that fired, and the exact outcome of the decision. This gives you a perfect enterprise-grade audit trail. For sectors governed by DPDP, GDPR, or complex financial regulations, having this level of continuous behavioral monitoring isn't just a nice-to-have, it's an absolute non-negotiable requirement.
So for organizations that are finally ready to transition away from chaotic AI generation and move toward truly governed intelligence, you really need to pilot test the Raksha AI model and see these architectural guardrails in action for yourself. You can easily schedule a demo or set up a pilot implementation by visiting their website at buddyengine.com, or you can shoot an email over to hello@buddyengine.com, or even just call them directly at +91 6364 099766.
And I'm going to leave you with this final thought to ponder as we wrap up today's explainer. We are fully, entirely in the era of enterprise AI, and the organizations that fail to govern it, they are going to face massive operational instability and truly catastrophic data exposure. So the question is, will your enterprise choose to implement governed architectural safety today so you can safely scale those intelligence systems tomorrow? Or are you going to leave your critical proprietary data entirely up to unmanaged chance? The choice is absolutely yours. Thanks so much for joining me today, and keep learning.